Okay, this is a problem where they give you the area of the sector and they want you to find the whole area. So again, what I would suggest doing is using the formula that I gave you, where this is the sector area over pi r squared, and that's going to equal the central angle, and this is 360. So since we want to find that, since we want to find the area of the circle, that's going to be this right here. So actually, instead of pi r squared, we're going to put a there. So a is what we're solving for. The sector area is this red part, which is 35 square meters. We're going to put an a there. Central angle is 40, and 360 is on the bottom. Hopefully you can tell that 9 times 40 gives me 360, so this would be 1/9. And then cross multiplying, we get a is equal to 35 times 9, or a equals 315. So we end up with 315 square meters for the whole thing. Okay? And I think they make it a little bit more complicated, but we'll look at it anyways. Area of this, and then we have the conversion, and then the area of the whole thing. So 35 equals this. This is 1/9. So we'd multiply both sides by 9. We get 315 there. Okay, here's another one. For here, it says a rectangular wall has an entrance cut into it. You want to paint the wall to the nearest square foot. What is the area of the region you need to paint? So what we need to do is find the area of the whole thing, and then we're going to subtract out this part right here. If you notice, let's find the area of the whole thing first. The area of the whole thing, we've got 36 here, and 16 plus 10, so this is 26 feet. So the area of the whole thing is going to be 36 times 26. And if we get our calculator out, that gives us 936 square feet. Now we're going to figure out the area of this part, and then subtract it from 936. So we're going to do area of that part right there, which is 16 this way and 16 this way, so it's a square. So it would be 16 squared. That is 256. So that's 256 square feet. For the area of this part, if you notice, it's half of a circle, so we've got to figure out half of pi r squared. So for this part right here, since it's half of a circle, we can just say half pi r squared, or in this case, half pi times the radius. The diameter is 16, so the radius is going to be 8. So we've got 8 squared there. So that gives me, let's see, 1/2 times 64 pi. And that's going to give us 32 pi. I'm going to keep it like that for right now. Our total area is going to be that 936 minus 256 plus the 32 pi. Okay? This is where we get our calculator out. So I would figure out that 256 plus 32 times pi, and that gives us, and just keep that on your calculator. So we've got 936 minus, and this is going to be approximate now, 356.53, and we're going to subtract that from 936. So if we subtract that from 936, we end up with about 579.47 square feet. and these should all be square feet here. Sorry about that. Okay, so we end up with 579.47. So if we look at this, we're doing the area of the wall equals the area of the rectangle minus these two added together. So this, they did 180 over 360, but we could recognize that as 1/2, I hope. If we calculate all this, 936 minus 32 pi plus 256, and we get 579.47, which I believe is what I got. Yep, 579.47. Okay. And now we're doing another problem where they give us the area of this red part. We want to find the area of the whole thing. So again, we have sector area over the area of the whole thing. Remember, this is pi r squared. If they asked for the radius, we would just put pi r squared there. And then here we're going to do central angle over 360. So the sector area is 214.37. The area is what we want. Central angle is 85, and that's out of 360. We can divide both top and bottom by 5, it looks like. I think that's probably about it. So the top would be 17, and the bottom would be 72. You don't have to do that, but I think it helps me. So we'd end up with 17a on this side, and on the other side we'd end up with 72 times 214.37. That would give me 15,434.64. We're going to divide both sides by 17, and the area is going to be 907.92. So we end up with 907.92 square centimeters. Okay. And here's another one. We're going to have to find the area of this half of a circle plus the area of this triangle, and adding them together, we get the area of this part right here, which ends up being 1/2 pi, and the radius, we have a diameter of 7, so that makes the radius 3.5, so we'll do 3.5 squared. This gives us 1/2, actually let's just calculate that out. So we get 3.5 squared, which is 12.25 divided by 2, gives us 6.125 pi. And if we calculate that, let's keep it like that for right now. Let's do the area of the triangle now. We've got this triangle here. We know the base and the height are 7, so it would be 1/2. The base is 7, and the height is 7. This gives us 49 divided by 2, which is 24.5. And for both of these, it's square meters. So to find the total area, we're going to add those two together. That gives us 6.125 pi plus 24.5. If you give me a sec, I will calculate this. So we've got 6.125 times pi plus 24.5. Should have gotten approximately 43.74 square meters. Okay, 43.74 square meters. And it says, if you know the area and the radius of a sector of a circle, can you find the measure of the intercepted arc? Well, let's see. Yes, if you know the area and the radius of a sector of a circle. I don't. Oh, okay, yes. How would you do that? We would know the radius here. we would know the area here, so we could plug it in and solve for this m here. Yeah, so even on mine, I'll show you on mine what that would look like. So we've got sector area, we'll do this one more time, and we've got pi r squared here, and the thing that we don't know is the central angle, which is also the measure of the intercepted arc. So they're really asking for that. Central angle and 360 here. So what we would do is we would multiply both sides by 360. So if we did that, those would cancel, and the central angle, which is also the intercepted arc, would equal 360 times the sector area all over pi r squared. Okay? So that would work. And again, that's what they're saying here. 360 times the area, the sector area, over pi r squared. And we're done. Thanks.